Area is measured by the number of square units, whether they be square feet, square yards, square inches, that are contained in a region. Now here's a region. The area of this rectangle is 15 squares. 15 square, well, we're going to say feet. It's probably 15 square inches. Now how did I get that? Well, I just counted. Okay, I was 15. I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. But if you measure the width and the length of a rectangle, now this only works for a rectangle, hopefully you see there's a relationship between the width and the length and the area. Because if we have something like this that has 9 inches by 7 inches, and you're thinking to yourself, there's too many to count, or you could count it but you don't feel like it, you can use that relationship, and that is that the area of a rectangle is always the length times the width. That's a fast way to count the boxes. So the length times the width in this case saved me from counting all those squares is 63, and you have to say 63 squares or 63 square inches. So that's the area of this thing. Remember that formula. Area is length times width for a rectangle. Well,
are you pondering what I'm pondering?
Let's consider the same formula for a square. A square is a rectangle, it just has equal sides. As you can see, you can count that that has 9 squares. 1, 2, 3, 4, 5, 6, 7, 8, 9. And it is in fact a square because the sides are equal. 3
I know that, dude.
by 3. Okay, the sides are the same. It kind of is length times width, isn't it?
Hey, wait just a minute.
But if you said that the length and the width were the same and called them sides, there's another way to write this. Instead of side times side, you may see side squared, which means 2 sides. Side times side, doesn't it? You know what exponents mean. You can see that it's going to be 3 squared, and what is 3 squared? But 9. 9 square feet. So if we gave you something like this, and we told you it was a square, we really only need to give you one side, because the other one's the same. And the area of this square is going to be side squared, or side to the second power, is 7 to the second power. Now don't you say 14. What is 7 to the second power? Is 7 times 7, 2 times. It's 49. And always say 49 square inches when you're measuring area, because that's what you're measuring, how many squares.
And now for something completely different.
Let's look at another use of this. Circles. What the heck is a circle anyway? Well, you know the definition, you thought you knew, but if I had asked you to define it, you can't just say something round, okay? Actually, a circle is defined as a collection of all points, and they're black in this case, all the black points that are a given distance from a center point. That given distance we call the radius. Notice that the interior, what you would call the interior of the circle, is not included. The circle is only the black points on the outside, and the radius is the distance from the center in every direction out to the point on the circle. That's called the radius. Now, if we take a radius and put it next to another radius going in the exact opposite direction from the center, guess what we get? 2 radiuses? Well, you're right there, but we also get what's called the diameter of the circle. Okay, not a spoke of the wheel now. This one goes all the way across and goes through the center. The diameter of the circle. Now, there's another word. What about the actual distance around the circle, the black part? Now it's green. Well, that's actually called the circumference of the circle. So we have 3 words, the radius, the diameter, and the circumference. 2 of them are going to be easy to measure with a ruler. The circumference, since it's round, is going to be tough to measure, but we may need to do it. There's many things in our lives that are circular, and we need to know the distance around something. So,
Excuse me, Professor Brainiac.
I want you to think about something. Take a look at that diameter and make a guess. How many times do you think that diameter would fit around the circumference? And pretend, if you would, that you're in ancient times, because the ancient Greeks and the ancient Egyptians thought that it was 3. They thought 3 times the diameter was the circumference, was equal to the circumference. Now let's take a look. If I measure 1 diameter, 2 diameters, 3 diameters, doesn't quite make it, does it? So we can't use 3. And in fact, if you went to Greece or Egypt today, there are buildings that are still standing from ancient times. But guess what? None of them are circular, because they use the wrong number. They use 3. Actually, it's a little more than 3, as you can see. And this measurement, this multiplier, if you would, of the diameter to get the circumference, a lot of people get credit for it, but generally the credit for finding an approximate number to use is given to a man named Archimedes. And he approximated this number to be...
Excuse me?
3.14, or 3 and 14/100ths. Archimedes said it was about that. But we also know that it's not exactly that. The number that you would need to multiply by to get the exact circumference, you'd need to multiply the diameter by to get the exact circumference, is actually an irrational number, a number that goes on forever and never repeats. So we can never really capture it or never really write it down. I love that word, irrational. I can never really understand that number because I can never really know it. I only approximate it. Now, since we can only approximate it, we represent it with, because since we can't write it down, we represent it with a symbol, or actually this is a Greek letter, makes sense. The Greek letter pi. And pi is the number that you would multiply the diameter by to get the circumference of a circle. So, if I asked you for the circumference of a circle, you would say that it is pi times the diameter of that circle.
Oh, yes.
Okay?
Alrighty then.
Well, let's look at an example. Suppose
Yoink.
that I told you, or you measured, the diameter of this circle to be 9 inches. And I asked you for the circumference. Well, you could tell me the circumference was pi times the diameter. Pi times 9. So you'd say pi 9, but we don't say that. Typically we say 9 pi, or in this case, since it's inches, it's very important to use the unit, 9 pi inches. And that actually represents the exact answer, 9 pi inches. But if I needed to know exactly, if I needed to know an approximation, a usable number to go to Home Depot and tell them how big to make a hole or how long around a circle needed to be for a table, well, 9 pi isn't going to make it because I can't measure that. So what I do is I put in an approximation for the number pi, which is...
I know that, dude.
Which is 3.14, as we said, and 9 times 3.14...
Well, ooh-la-dee-da.
Now that's a usable number. 9 times 3.14 in this case is 28.26. So a very close approximation for the circumference of this circle is about 28.26 inches. Now remember, that's inches because it is a length. Now let's talk about the area of a circle. Now this is going to be a problem because up to this point, area has been measured in squares, and it will continue to be measured in squares, but squares are basically length times width, aren't they?
Yes, you're in deep doo now.
So, and it's going to be trouble trying to fit squares into this round shape. So we have to come up with a little bit of a trick, and you won't have to do this trick, but I'd like you to appreciate it. So I'd like you to consider the following. If we took this circle and divided it into 4 equal parts, Now I'm going to take one of those parts and I'm going to set it aside and kind of put it in that position, if you would. Now there's 3 other parts out of the 4, isn't there? And I'm going to arrange them in such a way that they kind of alternate size like that, and put them together as pieces of pie. Now that doesn't look like anything familiar, I assume, at this point, but you get the idea of what I'm doing. Well,
Do that again.
instead of breaking it into 4 parts, consider breaking it into 8 parts and doing the same thing. Same circle now. Let's look at one of the parts and set it aside and kind of set it up in a position. Now there's 8 parts. So I'll set it up and I'll put in the other, kind of alternate turning each part over, kind of. And let's see, that's 1, 2, I have 8 parts, so I need 6 more.
Making copies.
And that circle could be put in a situation like this. But once again, it doesn't look like anything that we're familiar with, especially with area. Well,
Do you mind telling me what this is all about?
I'm going to continue on and break it up even further. And I could break it up as far as I wanted. Let's break it up really into a lot of teeny pieces. Okay, that's enough, I guess. That's like 32 pieces. Okay, and I'm going to take, once again, one of those pieces, and I'm going to set it aside and then arrange all the other pieces in an alternate fashion. I set it aside up on its hoot. Now if I put the other pieces alternating, flipping them over, and I put them all into the picture,
Making copies.
well, I hope you appreciate now the picture's starting to look like something that we could find the area of.
Hey, wait just a minute.
It's not a circle, but it forms a rectangle. Now, a rectangle's length,
I know that, dude.
we know how to do that. The area of a rectangle is length times width. Of course, we'll have to know in circle language what the length is and what the width is here. The length, the length is going to be this distance here. And what is that? That's not the circumference, but half the circumference. That's half the circumference of this circle. So that would be the length. And we'd multiply that by the width. Now, what is this width in circle language?
Hey, that's just crazy enough to work.
Actually, the radius. So we could get a very good approximation of the area of this circle by multiplying half of the circumference times the radius. And of course, I hope you appreciate, if we broke it up even further, it would actually look almost exactly like a rectangle. Now, half the circumference is half, what is the circumference? Diameter times pi. Half diameter times pi, because the circumference is diameter times pi. Now I'm going to get a little squirrely with the diameter, because I know the diameter is 2 radiuses. So I'm going to replace that with 2 radiuses. And remember that half of 2 radiuses is 1 radius, isn't it? Now, if you look at what you have here for a formula for the area of a circle, we have radius times pi times radius. I smell an exponent here. I have 2 radiuses. Actually, it's called radii.
Hey, man, check it out, huh?
What you end up with is something you might have heard from before,
How do I do it?
is pi radius squared, or pi r squared. And that is why the formula for the area of a circle is pi r squared. Pretty cool, huh? Okay, now let's summarize.
Now you listen to me. I want details, and I want them right now.
Okay, you're going to need to know that you can find the circumference of a circle,
Darn tootin'.
the circumference of a circle, by measuring the diameter and multiplying it by pi. So the circumference equals pi times the diameter. Pi could be in the form of a symbol or in the form of 3.14. Now, if they give you the radius, since the radius is half of the diameter, you could also multiply pi times 2 radius, because 2 radius is the diameter. Okay, so that would be how you'd find the circumference of a circle. Now remember, to find the area, we're going to be measuring square units, and the area formula is not pi times 2r or pi times d, but rather pi r squared, or pi r times r. Now,
Excellent.
if we need an estimate, an actual number, a usable number, then instead of pi, put in 3.14, and you'll get a usable answer. Let's look at an example.
Allow me to demonstrate.
Okay, in this case, I've given you that the diameter is 10 inches. So you should be able to find the exact answer. If I said exact, that means use the symbol pi, by multiplying that diameter by pi. Pi times the diameter is the circumference. So you would say
You're absolutely correct.
that the circumference of this circle is 10 pi, in this case, inches. Now, if I ask for an approximation, a usable number,
Now I want answers. I shall have answers.
that approximately equal to symbol there tells you I want an approximately equal usable number. So I would take an approximation for pi, which is 3.14, and then multiply it by the 10, and that's easy to do here.
Oh, no.
And I would apparently find out that it's 31.4 inches around that circle, the circumference of the circle. Now, if I asked you for the area, the formula for area is pi radius squared. Now, they didn't give me the radius in this question, but I can find the radius. If the diameter is 10, the radius, of course, must be half of that, 5. So the area would be, what would the area be for the formula pi radius squared? Would be pi 5 squared, or 25 pi. And it's important here that we're measuring square units. So for the area, you're not going to say inches, you're going to say 25 pi square inches. And if we want a usable number again,
I'm back, baby!
once again, we replace pi with 3.14, and 25 times 3.14, I guess we'd get
I'm dangerous. I'm very, very dangerous.
we'd get 78.5, and again, we're measuring area, 78.5 square inches. Okay? Okay, you need to move it, bub, and do your homework.